Hi, I'm Roger from Tor. How many people were here on Sunday for the Cypherpunk Congress and saw me talk there? I see quite a few hands. Okay, great. So I'm going to talk a little bit, once I have slides, about what Tor is and how it works and so on, but I'm going to aim to hit some things that I didn't talk about on Sunday, such as the censorship side of things, the onion service side of things, and so on. So Tor is a free software project. Tor is a network of volunteers around the world. Tor is a community of researchers who are trying to figure out how to build better privacy tools. Tor is a group of scientists and grad students and researchers who are working to break it and fix it and so on. Tor is a network, it's a protocol, it's a lot of different things in the umbrella. So in terms of how it works, a lot of people look at it in terms of Tor browser. It's a fork of Firefox that tries to fix all the privacy level issues at the application layer. I'll keep pausing until maybe we have some slides. Are we working on it? We're doing it? Okay, great. Okay, yep. So the way that Tor works in practice, there's a network of volunteer relay operators around the world. We have about 9,000 relay operators, and your Tor software, your Tor browser, builds a path through 3 of these relays, and the goal is that no single relay gets to learn both where you are and also what you're connecting to. So you can imagine a world where I'm in Tunisia and the monopoly telephone company in Tunisia gets to see my internet connection. They get to see where that I'm connecting to Tor, but they don't get to learn what I'm doing inside Tor. Or maybe an adversary instead would be on the web server side. Maybe they're watching WikiLeaks and they want to know who is connecting to WikiLeaks in order to make a list of suspects or track people down or things like that. Or maybe the attacker's somewhere in the middle of the network. Maybe it's NSA or AT&T or Deutsche Telekom or something like that. So these are all sort of different adversaries that we think about in terms of how to protect you on the internet. I see that we're still messing with slides down here. Sounds great. What? I'm going to get myself back on track. Okay, so, wow. I can see why Vitalik is wearing the sunglasses in each of these situations. Okay. So I talked about the anonymity side, how what sort of adversaries we worry about. Another key thing to think about, anonymity is not the same as encryption. When you're using encryption, you should use encryption, but even then, somebody watching your network traffic gets to learn who you're talking to, when you're talking to them, how much you're talking to them, and that metadata is the sort of thing that is exactly the sort of thing we're trying to protect. So there are a bunch of, I guess we're also part of a bigger end-to-end encryption fight that's going on these days. I'm going to keep holding my hand up here so that I can see any audience members. So there's a fight going on in the WhatsApp world, there's a fight going on in the Signal world, and part of the challenge that we have is governments keep trying to put backdoors or remove security from these sorts of things, and they're arguing that they need to do it in terms of we need everybody to be unsafe in order to be able to make people safe. And that is a challenging, ongoing discussion that, from our perspective as technologists, of course, the best way to protect all the people, all the children, all the vulnerable, marginalized people is to give them their own choice over whether they have encryption and so on. So that's an ongoing challenge that we need to keep thinking about. In terms of how I frame these things for the world, so when I'm talking to the professors and grad students who are writing the research paper side, I work on anonymity. When I'm talking to my parents, I work on privacy tools, because privacy tools are much more of a value that everybody can understand. When I'm talking to companies like Google and Walmart and so on, I work on communications security. Because if you go to a company and you say, I've got a privacy tool, they're like, privacy is dead, the Oracle guy said so. So trying to figure out how to frame these things to the different groups that you're talking to is part of the key. And then when I talk to governments and militaries, I work on traffic analysis resistant communication networks. Again, it's the same security properties, it's the same network. It has to be the same network because you need your Egyptian activists and your FBI agents and your random people who just read the NSA spying article all into the same group. If you built an anonymity system only for cancer survivors, then everybody will know why you're downloading that system, why you're participating in it, and suddenly you don't get the diverse set of users that you hoped for. Okay, so a lot of people here in the recent years, everybody who's watched any internet advertisements have seen all the NordVPN, don't worry, 100% bulletproof, we'll keep you safe, we're in Switzerland, it'll be great. The challenge with all the centralized systems out there, it always starts with, we promise we're gonna keep you 100% bulletproof safe. Okay, we do look at your traffic, but we promise we're not gonna log anything. Okay, of course we write everything down, but we promise we're not gonna reveal things. Okay, well of course we answer subpoenas, and of course we answer them from Saudi Arabia because they're a government and we have to follow all governments. So that privacy by promise approach is a real challenge in actually providing real privacy because there's no way for you to verify, and there's no way for you to learn whether they're following through now or whether they changed their mind and stopped following through later. Maybe the company got sold to a data mining corporation, which seems to be what keeps happening to the VPN companies. So part of the goal of Tor is to distribute the trust over multiple relays, so there's no single point. It's not, I have the data and I promise not to screw you. It is, I don't have the data, so I can't screw you. That's where the decentralization comes in, and it's the key for how to make all of these things safer. Okay, so there are a couple of example case studies where we talked out and where we went out and talked to a bunch of users about what sort of things they value Tor for, and so I've got two sort of case studies to talk through. One of them is the obvious one. It's the political activist. Of course, I was on the internet arguing for my government being different, and now I'm on the list of people who had argued about that, and now they're already watching me, and using tools like Tor lets me be able to engage in civil discourse and discussions about how to change the government and how society should be better in a way that doesn't necessarily reveal who I am until I'm ready to go public about it. So that's the obvious, simple, it's the use case we're all thinking about in terms of I want privacy on the internet in order to live my life on the internet. But the other use case we were talking about on Sunday was there was a doctor saying, I live in Washington, D.C., and some senators are my patients. And when the senator comes to me and talks about an interesting medical condition that's maybe embarrassing or something, of course I don't immediately go to Google and start researching the medical condition right after the senator comes in and talks to me, because that senator is in charge of deciding who buys the billion-dollar fighter plane, and there are a lot of companies out there that would really love to get any sort of leverage or blackmail or whatever they could on the senator. So not only is my job as a doctor to keep them safe at the medical health layer, but it's also my job as a doctor to keep them safe at a cyber or security layer. I need to, keep the whole picture in mind. Okay, so how do we actually measure this stuff? How do we decide what it means to be secure? How to, if I give you Tor Network 1 and Tor Network 2, which one is safer? And part of that is the diversity of where the relays are around the network. So we've got 9,000 relays, but imagine at the beginning, the Tor network was all in Boston. And that meant that if you're able to watch the traffic in the Boston ISPs, then you're able to see a lot of the different flows. And if you're good enough at math, maybe you can match up which flow coming into the Tor network goes to which flow coming out of the Tor network. And that means that as the Tor network gets not just bigger, but also more diverse, the set of attackers who are in the right place to see the traffic flows in the first place gets smaller and smaller. So at this point, the internet is not as decentralized as I'd like. We can imagine NSA and other groups are pretty good at watching a lot of it. But the smaller adversaries like French intelligence or something, maybe don't get to see enough traffic in the first place. So it's not a question of how good they are at math, it's a question of how much of the overall internet they've started surveilling. And then the second way we can think about security is diversity of types of users. So you might imagine yourself as an engineer, most of you are, you've got a bunch of Tor users in Iran. If you're the engineer, what do? You keep arresting Tor users in Iran until there aren't any more, right? I mean, that's the algorithm that we, the censor, should do. But the reality is, most of the people in Iran are using Tor because Iran blocked Facebook. They're trying to get to their pictures of kittens just like everybody else on the internet is trying to do. And the government stopped them from doing that, so they install some tool like Tor in order to get around the censorship to do what they already wanted to do on the internet. So that ordinariness is really important for the small subset of people there who are actually trying to work through how to reorganize their government and make their society better. So that diversity of types of users is really key for why being a Tor user in a place like Iran is okay and safe. Okay, so everything I talked about so far is Tor at the network layer. I want to connect to a website without the IP address, without somebody watching me learn where I'm going, and without somebody at the other end learning where I'm coming from. There's a whole other layer that we need to think about, which is the application layer of privacy. So in our case, in Tor browser, we need to fix all of the, not just cookies, but which fonts you have installed, how many pixels by how many pixels your browser window is, a bunch of other cookie-like things at the browser layer. So we have Tor browser, and part of the challenge there is every time Firefox comes up with a new version, we have to go through all of the weird new JavaScript APIs that they just put in. A while ago they had a battery API where the website can ask for very specific details about how much charge, capacity, and so on for your phone's battery, and that is a thing that they can track you with. There's another one where Chrome wanted to make browsers be the operating system for everything, so of course you want to use Chrome to control your Xbox. So now there's a JavaScript API where the remote website can enumerate all the UUIDs of all attached USB devices because they want to, make it easy to use your Xbox with Chrome, with whatever your system is. And that sure is another tracking mechanism. So we have to look for all of those various tracking mechanisms and resolve them. And part of the challenge is incognito mode, private browsing mode, things like this. They sound great, right? Private browsing mode, I want private browsing mode. But private browsing mode means somebody looking at your hard drive after you've browsed doesn't get to learn what you did. It doesn't protect you from the website you go to, from your internet provider, from the advertising company, from all the adversaries that we actually do want to care about. Okay, transparency. Transparency for Tor is really important because part of it is community building. Of course, it's free software, open source software. Of course, we give you specifications and design documents. And of course, there are hundreds of research papers in the academic world talking about how to keep these things safer. But also, of course, we identify ourselves. Hi, I'm Roger, I wrote Tor. And part of the reason we do that is to build the community so people know who we are and can turn into advocates for Tor on their own, but also can trust that we're the same people year after year and we keep sticking to the same values and so on. And part of the challenge there's always somebody who's like, oh, haha, the privacy people are talking about transparency. That's stupid. Transparency is a choice that we make because privacy is about choice. So I choose to be transparent. I'm having my privacy and using my privacy by choosing to be public and open. I still have the privacy. That's what I get to do by having it. Okay. One of the challenges we always have is, okay, but what about bad people? And there are bad people on the internet. Sure, some of them use Tor, sure. Part of the way that I think about that, so you start off thinking, okay, it's a double-edged sword. Like you've got the good people, you've got the bad people. You need to accept both of them. It's a privacy system. But the reality is the folks who have a lot of power on the internet already, whether they've got military power or police power or monetary power or whatever, those folks are doing fine. They don't need Tor. Whereas the people who don't have much power, they're in marginalized or vulnerable situations, or they live in countries where they're at risk. Those folks are the ones that need privacy, safety, security, anonymity, Tor a lot more. So one way of looking at that is, if you take Tor away from the world, the Russian mobsters are going to keep doing Russian mobster things. And if you take Tor away from the world, the blogger in Egypt is not going to have another option. So it's not just there's good and bad, you have to accept both. It's that technology is fundamentally political, and you need to think about the architecture of the system you're building. Are you concentrating power in the middle, like Google Docs, where all the power moves into the huge companies? Or are you concentrating power at the edges, at the leaves, like a peer-to-peer decentralized, where you're empowering users to decide for themselves what they should be thinking about? Okay, so that was the first third of the talk. Sorry there aren't any slides, but hopefully you're keeping up. The second third is on the censorship side of things. So it started off with people in China contacting me saying, this is awesome, I can read websites that China has blocked. And then by using Tor, I install Tor, I route through the Tor network. BBC.com doesn't work for me, but when I'm using Tor, it does. And then I'm thinking, okay, well that's great, but there are 9,000 public relays. China's just going to block them, and then Tor won't work anymore in China. So then we started thinking about the back and forth arms race, and basically the approach we have is called pluggable transports. The idea is Tor takes care of the privacy side of things, but at the Tor browser side, we have another module that transforms your traffic in some way that the goal is to change the protocol you're speaking so that it's a protocol that the censor isn't willing to block, and to change the destination you're talking to so it's not an IP address that the attacker knows about or is willing to block. And one of the popular pluggable transports these days is called Snowflake. It transforms your traffic into WebRTC so that you look like you're doing a video chat, and the censors allow most video chats. And one of the cool things about WebRTC is that browsers do it natively, which means in the older pluggable transport design called OBS4, obfuscating proxy, we've got thousands of people running those bridges to help people get into the Tor network. But the way that you install an OBS4 bridge is install Debian, apt install Tor, edit this text file, open this port on your firewall, and I've just lost most users at that point. Whereas in the Snowflake world, install this browser extension. And now you'll be one of the hundreds of thousands of volunteers routing people from censored areas in Russia or Iran and other places through you into the Tor network. And we had our first real test. Oh, thank you. And our first real test of Snowflake came 3 months before Russia invaded Ukraine. They did a bunch of crackdowns on a lot of different privacy tools, including Tor and Snowflake. And we fixed the way that they blocked Snowflake in like 12 hours because we happened to be paying attention at the time. And a lot of people who used to be using other approaches to reaching the Tor network or other VPNs that stopped working, 5,000 or so people switched over to be using Snowflake, 5,000 average simultaneous users during that month of December, right before Russia invaded, which was awesome. And then 6 months or so after that, Iran had their own next round of their revolution, and Snowflake became the main tool that a lot of people were using for that weekend. We had some hundreds of thousands of simultaneous users. There was a day, I think it was October 1 during that year, where Tor was the #1 app on the Google App Store, and Tor was the #2 app on the Google App Store. One of them Tor browser, the other one Orbot. So that, of course, doesn't continue over time, but that's an example where building tools and then testing them in the real world and growing your users and fixing scalability issues turned out to work really well. Okay, and then the other thing I wanted to talk about in the last couple of minutes is onion services. So I talked so far about I want to go to a website using Tor, I build my 3-hop path through the Tor network, and I pop out and I go to bbc.com or something like that. Once we've got this 3-hop circuit as a building block, we can glue 2 of those circuits together where the client talks into the Tor network and the Tor Onion service client talks into the Tor network, and the network glues them together in a way that I don't have to know where the website is that I'm going to. The website doesn't have to know who I am, where I'm coming from. And so it started off as sort of an esoteric tool of like, let's make peer-to-peer work better. But now we have BBC running Onion services. We have Cloudflare running Onion services. So they host, what, 20% of the web or something? So 20% of the web is available as Onion services these days. And actually the reason why I'm here is because a couple of years ago I met the Ethereum Foundation people at the FOSS Asia conference in Hanoi, and I just found this graph on the internet of the Bitcoin network and how many of the Bitcoin nodes are reachable by IPv4, IPv6, or Onion addresses. And if you look at that graph now, it's up to about 3/4 of the Bitcoin nodes are only reachable as Onion addresses. So we are the network underlying transport for the Bitcoin network, which is a bizarre world to live in. And at first I was thinking, oh great, they understand the privacy things, they've chosen it for all the right reasons. And then I was talking to one of the Bitcoin developers, and they're like, yeah, this allows us to do like NAT punching for free, and that's why everybody chooses that approach. So they get all the privacy properties for free, and also they get the usability improvements so they don't have to mess with their firewalls and so on. So that's the world that they've been living in, and why they've chosen to use Tor. And part of our challenge here is to be the critical infrastructure for all the other privacy projects out there that need this sort of thing. Okay, in my last couple of minutes, let me talk through a few other topics that I've been pondering lately. One of them is the next round of the crypto wars. So it used to be that we argued about whether we can export RSA. We finally won that. And then we argued about whether users should have HTTPS by default. We finally won that. Now we're arguing about whether users should be in control of their own hardware and their software, whether you should be able to have end-to-end encryption in your WhatsApp, whether your iPhone should actually be your iPhone or is it Apple's iPhone. And part of the weird outcomes here is in this round of the crypto wars, the companies are mostly on our side. We've got Apple doing these huge billboards about how privacy is important. We've got Facebook saying, no, our users want end-to-end security, and that's why we want to give it to them. So it's a bizarre world now where it's not just a group of cypherpunks saying no, privacy is important. Now we've got these huge companies who are also doing it, which is, on the one hand, that's great. On the other hand, what Apple means by privacy isn't quite what I mean by privacy. Because they've got these amazing billboards like privacy is important, but what they mean is trust me. Give me all of your data, I will keep you safe. And that's the centralized version of privacy that isn't the one that I'm hoping the world will have. And I think from the decentralized crowd here, you'll agree. So part of our challenge is how do we use Apple's PR team to make the word privacy great without letting them take over what the word privacy really means, and suddenly it's like transparency from 10 years ago. Of course everybody is transparent, but what do you mean by transparency? So part of collectively our challenge is how do we keep the momentum of the right kind of privacy in order to get where we want to go. Okay, and then I mentioned on Sunday, but I'll mention it here, if you're connected to a university, I'd love to chat with you afterwards, because EFF has been running a campaign to get Tor relays running at universities in particular. We started with about 8 of them a few years ago, and now we're up to 43 different institutions around the world. We just added KAIST, which is the main technical university in Korea, and we just added a big university in Taipei. So if you're connected to a university around here, the only participating university we have in Latin America is in UNAM in Mexico City. There are no South America universities running relays. Please help us fix that. Okay, and I'm gonna let us continue with the next phase at this point. So Keep track of whether you're helping centralization or decentralization. Help teach your friends about what privacy means. Consider volunteering as a relay or a bridge or a Snowflake. And also we're at a thing called Funding the Commons, and we are the Commons, and we're doing an end-of-year donation drive. So if you have some spare Ethereum or whatever, we'd love to help you help us make the world better. Thank you.